Go ahead.
Can I start? Okay. I'm Taniguchi from Ritsumeikan University. Today I will be talking about the hypothesis our group's research project is based on. And that is called the language emergence for Korea structure alignment. Actually, I gave this name yesterday. This is kind of tentative title. But I wrote an essay in the Science and Kagaku, the magazine, the Kagak. And today's talk is a kind of a summary of the explanation of the hypothesis. So sorry that I haven't written that in English, but I should do that ASAP, I think. Anyway, let me start. Okay, so I will talking about the hypothesis of language emergence for Korea structure alignment. Tentatively, I gave our abbreviation LQA hypothesis. So there are many several questions. Can humans align their Korea structure? If so, how? So, and how does language affect our Korea structure? And these are the questions about Korea. But from the viewpoint of the language evolution, another question is why did humans create language? Is it related to consciousness in some way? These are the kind of intertwined questions, I think. So through the discussion with Tsuchiya-san and others last year, we reached some sort of hypothesis. Maybe humans create language in order to align their Korea structures with others and become able to understand each other via semantic communication, the linguistic communication. This is a hypothesis, and I think this is a new idea. And to explain this hypothesis, I draw the kind of figure on that essay. So that maybe a bit complicated. I would like to explain step by step. So basically, there are two people here, and recently my notebook become heavy. Okay. Anyway, she had have multimodal experience through the interaction with the environment, and she has her own experience as well. Through such kind of multimodal, through such kind of experience, perception and actions. So based on such multimodal sensor information, she may form some sort of internal representations. Maybe that can be observed as a kind of brain activity. Anyway, so we sometimes call it a kind of the multimodal categorization or multimodal representation learning or something. And they are the kind of internal phenomena. But when we communicate, we represent such kind of their kind of ideas and concepts and feelings in natural language or using other kind of signs. So we can have a linguistic communication. But basically, the originally we don't have any shared symbol systems, linguistic system. So from the development, from the evolutionary viewpoint, we need to form some sort of shared symbolic system. So you can consider this as a kind of Japanese or Chinese and English, but more locally, that we can form a kind of local language in some sense. So to communicate in a to communicate globally, we need to share the interpretation of each word and the sentence, and depending on the context. And that's so by sharing such kind of symbol system, we can communicate and we can use language in an appropriate manner. So, when we use language, such kind of language has some sort of structure, and that can affect our internal representation. So through such kind of process, the language, the formation of language can affect our Qualia structure. That's a kind of rough story. So, maybe I must repeat the same thing, but let me explain what is symbol emergence, what is symbol emergence system. This is the figure I often use. So maybe I repeat the same explanation, but basically we form the internal representation system through representation learning. This is based on multimodal information. And after that, then maybe this is related to the Qualia. And we have the semiotic communication with others using language. But we need to coordinate our use of language and interpretation of language. And through that process, we gradually organize the symbol system in our society or in our community. And so if we follow such kind of rules or system that has caused in the society, if we follow the linguistic rules, and we can use such kind, we can use language for communication to coordinate our behaviors. So, but if we do not follow such kind of rules, we cannot make use of the power of language. So this can be regarded as some sort of constraints to our behavior and the linguistic communication. So this kind of bottom-up formation of emergent symbol system and top-down constraints by the symbol system. This kind of loop is called micro-macro loop in complex system. So this gave us a kind of understanding that the language is not a kind of pre-existing stuff, but some sort of dynamic phenomena organized, emerge in this complex system. We call this multi-agent system, symbol emergence system. Anyway, so once the language system, symbol system emerges, and actually we have some sort of symbol system in our society, so we need to learn how to use that and internalize linguistic, linguistic knowledge, and understand and relate that to our experience. So this part is corresponding to the first questions. And maybe before going to that, I want to mention the current trend about large language models. Recently, the large language model is booming, as you know. So when I revisit what is large language model, so I can give this kind of very simple explanation. We have knowledge of language in a distributed manner, and we produce speech signals and write text in a daily manner, and that gradually, and actually nobody has a perfect language system in our society, and the language system is a kind of abstract concept or something unseen in our society, and there is but a form implicitly, and this affects our knowledge of language as well. This kind of loop is happening always, and as a result, recently we can the internet we have a huge digital resources about language. So because we post many blogs and tweets and news and so on, and by internalizing the huge language resources into the huge giant neural network, so the neural network can internalize the knowledge of language and somehow implicitly infer, not the reasoning, so infer infer the use of the knowledge embedded in the linguistic system language. The ChatGPT and other large language model can perform well. So this is
just a quick question.
Yeah.
So this is all great summary on the explanation of the LLM. That I'm curious about whether if the knowledge conflicts. Yeah, one says the sky is blue and the another says sky is brown at the same time. How does it deal with it?
Maybe that can reach that probabilistically. So 50% brown and 50% is sky.
Or then the majority rule basically then.
Majority, yeah.
So then,
so this is statistical running.
I see. So then that implicitly says that the fewer people's opinion will be not represented or taken out.
Basically. But the proof that this is not the kind of argmax like stuff I have said. So the neural network model kind of progressive distribution. Basically the theoretically that keep some minority information as well. So because of that, if you input some context, or that can be written as a kind of the prompt information, maybe we can extract the minority information in some sense.
I see.
That's correct. So and when I had a chat with the researcher from Spain, I forgot the name, but kind of minority language in Spain. Catalan, not minority, but the Catalan is a kind of that they are taught in high school, junior high school, Catalan, but they never use that in many regions. Like a coupon in Japanese, we learn that at the school, but we never use that basically. So he is from such kind of region. People use the Catalan, and he asked the question to ChatGPT in Catalan, and actually ChatGPT answered the question by Catalan using Catalan.
Appropriately.
Appropriately. He said it's very Catalan-like. Right. So it's interesting.
In Japanese, then we can also ask in like a common kind of way, and then they actually answer in like I mean we can try right now.
But her said that something problematic stuff in ChatGPT is maybe they internally use a kind of machine translation. I said that. So Japanese corpus is not sufficient. So that basically they mix that kind of information by using the machine translation. So I don't know as happened.
I see.
Maybe we can test. And so large language model is nice. But before the large language model, the GPT-3, we have BART and Waterberg. They are also large language model. Language model. So the distributional semantics is the kind of basis of the power of language model. So actually without any perceptual information, sensor information, just the kind of internalize the modeling the sequence of words, the language, the internal representation can found the relationship between words. So this is well known, I think. And somehow it can say that the just learning the learning language can discover some latent structure of the word. So and so the in our through our study in on the symbol emergence in robotics, we have been conducting a study, the kind of joint learning language and the multimodal information. So naturally, we have been thinking about the integration of large language model learning and the representational learning. So in such case, maybe the structure found in large language model can affect the structure the found through the multimodal sensory motor learning, representational learning. So that will give some sort of the top-down constraints to make the representation for perceptual information aligned, giving some structure. So if two, the first how to say sub hypothesis is that question if two people learn the same language simultaneously, maybe they can receive the similar structural constraint to their latent representations. So this is the first question: does learning the learning language facilitate Qualia structure or people aligned? So this is the first question. That maybe this can be this kind of question can be answered by conducting by creating a model, computational model that combines the large language model and the representation learning. And this is the first part.
And also the same, the opposite side of the same coin would be people speaking different language should have a different structure.
Yeah, I think so. Yeah, that's also an important question, I think.
Will you predict that for the color and the emotion structure?
And how to quantitatively evaluate that?
Alignment.
Yeah, that's right. Maybe I think so, but of course I'm not sure if we can get that kind of clear, distinctive result because of the kind of the how to say uncertainty in the data set and so
we know that the colorblind people and the normal people don't align well. That's for sure. And then it seems like Russian people are probably suspected to have a different color structure, right? Yeah. At least the color language structure is probably quite different.
Yeah. That's actually the computational approach to the Sapir Whorf hypothesis. So it's super interesting.
Yeah, with the similarity rating, I don't think anybody has actually tested it actually.
And to achieve that, actually, that we need to have a kind of large language model locally in some sense. So that GPT-4 and GPT-3, they are owned by the OpenAI, and they train the system by using many language. So
yeah, that's LLM side, but on the Qualia structure side, if we can have access to the Russian people online, then we can test that.
That's about
psychological study, and also about the emotion. I don't know if anybody knows, but probably culturally, like Qualia kind of tested it, right? Like Chinese and American or India and American emotion structure. But they never use alignment or anything.
And also not emotion structure, rather, I think, face.
Yeah.
I mean, yeah, so the estimate, infer the emotion from human face or something.
But I think this kind of hypothesis to be put explicitly together with this prediction, even if it's wrong, that's I think it's fine.
Yeah.
Because now we can test it.
Yeah.
And if it doesn't work, then there is something to learn as well.
Right. ASAP. Sorry for my delay.
That's fine. All right.
Okay. Anyway, and here, so I think that, but this is a kind of a Sabio hypothesis, and I want to extend this idea further. So her say that this is a kind of a story from language to Korea, but to Korea to language. So this is I have been discussing. I have been studying the symbol emergence program. So actually, we form symbol system in a bottom-up manner. So creating creating symbol system and maybe it's the same. Creating a symbol system may help us to align our Korea structure. So that if so, that will become another explanation of language evolution. So I think that I have already explained this in the previous meeting. So actually, I have been studying the computation model of symbol emergence, and in recent study we proposed a method-based asynchronous naming game. This is a very simple naming game, but interestingly, this has a strong mathematical basis. And actually, in the communication, the agent A get visual multimodal visual information and form the internal representation. This is just a representation planning. And based on this internal variable, this robot sample the word W, and listener can decide whether he accept the naming or not probabilistically. So, and after turn taking, the game continues. So this
what does accept mean here?
Accept basically here, for example, in this case, the agent A names the object U, for example, U, and first the agent B thought, oh, this should be O, but when agent B accepts U, the O is overwritten by U, and oh, this root is U, so that I need to reform my kind of understanding, my categorization of my naming. That is the acceptation of the accept decision.
But by the way, Jun is asking that what you said in the previous slide, does it mean that do we need to learn language to have some coded structure?
No, I don't think so. So actually, the learning language will help. In my hypothesis, the learning language will help our Korea structure align. But the Korea structure can be formed. I think Korea structure can be formed on the sensory motor information alone as well as. But we cannot how to say, we cannot answer the question. but yeah, it's no. Yeah,
it doesn't necessarily mean that
Yeah.
we need to have language to have.
Yeah, that's right.
By the way, about this, overwriting
Mhm.
in the real kind of communication between, let's say, children and adults,
Mhm.
when this kind of thing happens, often I personally experience that I understand that there is a difference,
Mhm.
but I don't change. Kind of behavior is also true, right? Like I know that you tend to say "ooh," and I tend to say "oh," and then that's a sort of the difference. And then that kind of consistent difference, if it's accepted, it's a category theoretical kind of term of the adjunction. I just don't need to adjust it. So because if you do that, then I need to adjust everything, which is expensive.
Mhm.
But as long as I understand your kind of bias towards you,
Mhm.
then I can always internally translate.
Mhm.
Would you kind of consider that kind of strategy as well?
Yes, this is a very somehow simple model.
Simple.
Yeah, and in this scenario, what do you explain is considered that reject decline. So I will not update my my understanding of who or all. So that's reject. So maybe basically in this model, agents does not have others model.
I see.
So it's very self-enclosed.
I see.
So what's the objective function of this game?
That's the important point.
Yeah.
And actually, basically the basic objective function is the same as representation learning. So to predict the sensor model information. And so that also means
of your own, right?
your yes, that's right. So usually in this kind of emergent communication model, they tend to introduce the kind of external reward to models. But I basically I don't believe that our language learning is driven by a kind of external rewards. So basically this differential learning is theoretically closely connected to free energy principle and predictive coding. So it's better. I think it's better principle to explain this kind of phenomenon.
Can I ask one thing?
Yeah.
So in this case, they are learning the labeling of the object.
Yeah, that's right.
Okay. So what if like agent B had the experience of a blue apple for you,
Mhm.
but he's told that this is you.
Mhm.
But he's seen as red. In that case, they don't change they can't change perception. They are just changing the categorization, labeling.
So
Like inverted Qualia.
Yeah, kind of.
okay. Then they have a different perception system, you mean? I think it's so. Yeah, he don't need to change their labeling. But here we have one very important assumption. It's a kind of joint attention. They know they are looking at the same thing together. So at that moment, if the agent one, agent A, for agent A, it looks red, and agent B, it looks blue. It's okay. I mean,
But that's actually interesting because possibly, I don't know whether this is possible, but with this framework, and then given what we know about the color Qualia structure, let's say, from many people to be, let's say, gold standard, and then we generate an artificial color inverted person that does have a color Qualia inverted in some axis. And then they go through this kind of, task artificially. And then when they think that, green, it's always said to be red and so on. And then it's taught like that. But then as we kind of, demonstrated, you can't align it in this inverted way because the color structure is structure is not symmetric.
Mhm.
So at some point, this stress is so much that this inversion should be very unstable, and then it's kind of swapped into the original, standard kind of Qualia. Would it be possible to demonstrate that in this kind of modeling study, you think?
I don't fully understand it.
Like let's say, people usually think that, swapping or inverting the axis is totally possible between like a red-green axis, red-green to green-red. If that's possible, then Masarumi's, alignment kind of, procedure should also work like what's 93 color embedding inverted and then align. But we don't find it as a solution. That means that locally there is something, around red or pink or green. There is something special. So this kind of training throughout this 93 color training between this inverted agent and normal agent training, error turns out to be so strong that they need to actually flip this labeling system.
Basically, the current architecture, the current model, the basically update is performed for data point for each observations. So we don't have any kind of operation over every of this kind of structure.
That is a structure.
But of course, this is a constructive model. We can think about such kind of the operation as well. But kind of, I don't know. I'm not sure.
Currently, you're giving some kind of feedback on the particular object, right? Yeah. So if this changes into pair of object and then rating the similarity between the object, then that probably becomes similar to what I'm suggesting. But maybe we can talk about it later.
Sure. Yeah. So maybe we can skip and we can go forward. And actually I mentioned that this have a strong mathematical basis. Actually this game can be regarded as a kind of metropolis Hastings the algorithm. And that is a kind of Barco chain Monte Carlo. And this is a well-known approximate Bayesian inference. So this is regarded as a kind of the decentralized Bayesian inference technique. So theoretically, through this communication, the two agents as a system can perform the representation learning. And this kind of the formed shared the symbol system is a kind of representation that is good for predict the two agents observations. So this is the kind of basis of the theory of our metropolis name game. So this is the very simple experiment, and or using the emergence data set, the agent A look at the original emergence data, and the agent B look at the kind of rotated, obtain the kind of rotated the emergence data, and they performed the kind of the clustering, the representation learning. And if they don't communicate and independently perform the clustering task, the result is like this. And even without any supervisory signal or ground truth level, if they communicate and play the image naming game, the representation learning performance was improved actually. So because the individual setting, the no communication setting, the agent A need to form the representation only using his observations. But in this set, if we play the naming game, So you can use the group use the agent A's observation and agent B's observation simultaneously. That how to say that actually that increase the information. And okay, so the performance become better. And at the same time, so they have such kind of communication interaction. So that when we look at the inside of the agent's brain, I mean the kind of distributional representation. So we found a kind of qualitative the difference between those in no communication setting and with communication setting. But we haven't achieved and haven't done any quantitative evaluation. And maybe I think that we need to investigate what's happening here more quantitative manner. Well, okay.
So in this example, the number of vocabularies is predetermined, or this agent also tries to find the number of categories or number of
And
vocabularies.
in this setting, I know the number is fixed.
It's like 10. So it's- And this number is shared between agents.
Yeah, right.
I
I
see.
think it mathematically it can be extended, but we should say conduct abbreviation study as well. And actually how to say I think how to say not only this kind of categorical sign, but also that we need to we need to extend this model to kind of sequential information. Usually language is a kind of sequential data. So if the agent can use the sequential data, the number of categories become basically the infinite. So that is actually the current research topic, and the machine will do that. I think.
What if we set the number of categories like 5, even though the natural number of categories is 10? What happens? Like
Maybe they merge some numbers into one group.
yeah, and this group can be shared between agents.
That's interesting. If you have a let's just he is now reproducing the result of this paper.
Yeah.
That's actually interesting.
Yeah.
Because Qualia itself will be probably difficult to change.
Yeah.
But what we can typically learn is the abstraction of the concepts. And what you mean is, in a sense, kind of abstraction.
Yes.
Like
Yes.
even numbers to be considered as one category,
Mm.
and then that can be taught through the communication.
Yeah.
Or less than 3 as one kind of small number kind of category. That's a one-step abstraction.
Yes. So yeah, my guess is that if there is no natural categorization in the representation, maybe this category that the category emerged in one agent cannot be shared with the other agent. But so in this case, I say that natural categories are, for example, 10 digits. So clusters, even if that you don't have a language, with information of vision, that there can happen some 10 natural the clusters probably. In that case, this kind of conception can be shared between different agents. But I think that if you set the number of categories 5 for 10-digit case, there is no such natural categorization, 5 categorization In that case, it would be really hard to share this kind of abstraction between agents. Maybe, I don't know.
I think sorry.
Yeah.
I think they can form some sort of 5 categories. As you know, the MNIST data,
Yeah.
7 and 9 all match.
Maybe,
And
Yeah.
so the
I see.
9 and 4 is also match. And maybe such kind of category.
So there is some distance. Or,
Yeah, that's right. That's right.
That's true. Yeah.
And that depends on the distribution.
Yeah. These 10 digits are sort of equally distance. Then it's really hard to find. Hard to find some meta category. But
we have a strong assumption for joint attention. They get the per se. They get the observation for the same number simultaneously. I think that per se kind of per se even in same distance setting, some sort of the categories will be shared. I think, but that should be tested. That can be tested because this is a constructive approach.
Yeah.
Okay.
So,
So the second question is the single emergence facilitated Qualia structure of people aligned. So that is the next question. And actually, by answering these 2 questions, I think we can investigate the main hypothesis, language emergence for Qualia structure alignment hypothesis. And actually, we maybe based on this discussion, we also found several questions to investigate. Yes. We need to basically now this model only use the categorical signs. So there is no language model, maybe we need to introduce language models like at least LSTM or GRU, if possible, BAT and transformer to GPT, and so on. So and observe the kind of the effect of this distributed representations, and also but even in this kind of simple case, so the simple emergence can give some effect on the latent this distribution, internal distributions. Maybe as a first step that we should measure measure if this kind of interaction between the category formation and sign sharing, simple emergence can give a positive effect to the Qualia structure alignment. And also that we need to actually currently this metabolic Hastings name theory have some mathematical assumptions. Actually, in current pure setting, we cannot introduce the large language model in a straightforward manner. Maybe basically we need to extend the theoretical. I need to introduce some theoretical extension, and also that's also the next step we need to do. And finally, I want to introduce some preprint recently we uploaded. And if you have time, I would like to if you are interested, I would like to explain something. But basically, this is about the N agent extension of metabolic Hastings naming game. This theory was based on the 2 agent settings from the viewpoint of probabilistic generative model. Actually, we introduced some trick, and we show that we can theoretically extend the idea to N agent setting. And also it was demonstrated that no. Performing communication between randomly selected pairs is considered as an approximation of this extended version of the meta voice Hastings name game. And also we are conducting the experimental semiotic studies. So actually, we constructed that model shown before previously, but there is no guarantee the human actually performing such kind of game, use such kind of acceptance probability. And actually, we reproduce the almost the same setting, in this kind of communication experiment. And we recorded the data, and recorded the acceptance or rejection decision. And based on such kind of behavioral data, we train the probabilistic model and predict the acceptance or reject probability, and compare that with human behavior. And we showed that Metropolis Hastings naming game names decision probability, acceptance decision probability is it can explain the human behavior appropriately to some extent, that basically better than the baseline models. And also we also uploaded one survey paper for emergent communication, simple emergence, and also the explanation about collective predictive coding hypothesis. That basically let me explain a bit about the predictive coding hypothesis. This is a kind of summary of what I was talking about. Basically, in the context of predictive coding or free energy principle, what we are doing is kind of the modeling the world, and by inferring the by predicting the world, by predicting the sensor information, we can form the internal representations in other world model. This is a kind of predictive coding. And but there are many people, and each are performing predictive coding. But if we form the simple system through such kind of communication, and actually we share the latent variable, the external representation as language. So from the viewpoint, and actually interestingly, and from the viewpoint of language, if we consider language as a kind of subject, and language use us as a kind of sensor node, and we provide kind of information to the language, and we interact the world. We interact with the environment, and from this viewpoint, the simple emergence can be regarded as a representation learning, using people by language system. So this is a kind of view of collective predictive coding. So and this is a kind of that's just more so like my comment. So I think it will be even possible to investigate not only the consciousness of our mind, but also the kind of collective unconsciousness, said by Jung, and extending this scenario with constructive approach, even though it may be out of the focus scope of this project. So that's from my side.
Thank you. We asked a lot of questions and already made a comment during the talk, but is there any further comments, questions?
Yeah, so actually, Makiban now has already asked the same question that I have exactly the same question. What if we have, different robot A, have, or maybe I think it's better to put this question at different, so yeah, people said that, even though if our experiences is inverted, we will never know. But by using some kind of computational simulation, robot A has, the standard experience. Robot B has inverted experience. But yeah, and then we have, let's say, Japanese language system, and then force them to communicate. And then, if that question valid, so we will never know that they will have different experiences. Then these two robots should be able to communicate with each other without any conflict. But if it doesn't work, then maybe we should be able to see some kind of conflict. And I think computationally we can test this question. Does it make sense? Maybe it's almost the same as what now says, but
I mean, so that probably it's related to, in a sense, probably the philosophical or psychological discussion about how to detect a Qualia inversion, really. And if the Qualia space itself is already asymmetric, then there is a way to detect it behaviorally. And the communication is basically has been serving as a sort of behavior detection of such an abnormality. And I think and this kind of thing actually exists and has been utilized already in past, and that's the reason why we know that there is an colorblind people or synesthesia or aphantasia or many different kind of different experience. Like today, Taniguchi-san's peripheral experience turns out to not exist, right? But that's through our experiential recall. We can't fix his experience, but because his communication, we were able to see it. So I always feel like Dennett's claim that we can never know other people's experience is just false. Something like this, today's exposing reasonably similar kind of environment and getting systematic report, not only one yes or no kind of response. That's impossible to tell. But because I know Taniguchi-san, and then we have some kind of trust in his response, and that's the reason why I can start to believe that he doesn't see it, right? And we also tested experimentally different color, and he systematically say that he doesn't see it. So that kind of thing is the key.
Maybe this may not be a good answer, but when from the theoretical machine learning viewpoint, the graphical model is almost same as a multimodal representation market. So if the agent A has the camera and agent B just has a mic, so even in such a setting, they can form the simple system because this is just a kind of multimodal integration. And actually, yes, in the morning, when we walk with the Tsuchiya-san, and maybe then I talked about this, and maybe this you may found this is interesting. And actually, this is a very, very preliminary work, and my students is who conducted the human communication experiment, conducted additional experiment. And now now here the left right hand side is a robot, but please forget it at this moment. And for example, that if we created the data using several dimensional vector. For example, the one is representing the color, and one second is representing a size, and the third is representing shape or something. And the for one agent A, one-dimensional information is missing. And for the second agent, for the second participant, another dimension is missing. And let's play the naming game. So he conducted the initial experiment among two participants. And he said this was a very tough experiment. It was crazy. But anyway, for example, in data set one, so that has three variables: color and rotation and size. And in data set one, so for agent A, look at the left-hand side stimuli, and agent B like this. So and they play the naming game, and that's it. Oops.
One person cannot see the shape and one person cannot see the color.
That's right. And they play, and we haven't conducted kind of, we just ask a pair and we have said. So initially, in this setting, player B form, of course, this kind of categories. But through the game, they gradually form this kind of categories. So it was even so what he said, participant said, it's crazy. So he looked at the difference of the color, but for the player A, they are clearly different. So finally they reach this kind of agreement.
I mean, crazy by that you mean very stressful.
Stressful.
I think this can be actually interesting to sort of sell as a kind of potential projects or sort of the outcome of the project, in the sense that I mean, Yamada-san has been worked on patients, right, who had some kind of brain damage, and those people actually can be taught to behave like normally, at least at the surface, but they are very adamant and very difficult to correct their behavior. They say that they understand it, but they forget, and then they just do the same thing. It's like a difficulty of the rehabilitation. I mean, after this, maybe, like even if the player B comes to this kind of ABC situation through the learning, my prediction is that after that, if the player B plays with another player C, which doesn't have some kind of feedback like player A, which is like, sort of either self-playing or playing with another people without any kind of feedback, then he will revert back to the initial state, right? And that corresponds to sort of, the difficulty of the rehabilitation. Without understanding their world, we can't provide a proper rehabilitation.
I had a similar discussion with Yamashita-san, with Yamashita. And, yeah,
in
and
mental, yeah.
I want to use this kind of idea to, how to say, to investigate if they have a kind of the ASD or something.
Okay.
And also, yeah, I didn't think about the rehabilitation stuff, but yeah, it's also nice to think about. And also, actually, now we are, but actually, having this kind of experiment is costly. I mean, we bring two different people at the same time, and
Face to face,
but remotely is okay, but the scheduling required. And also, when we apply this kind of system to the psychiatry, the stuff, so how to say, the privacy issue is also. Now we are creating a kind of the human agent, computational agent system. So I think that in the previous study, we showed that the human behavior is similar to computational model. So now why don't you replace one participant by computational model? Even in this case, we can look at we can investigate the performance of we can check the performance of the human participant. So it to make such kind of experiment easier.
So I have a conclusion. So I totally agree with the Taniguchi hypothesis. But if so, or if it's correct, so why we don't use the more detailed linguistic communication to share the quality? For instance, we only use the red or some very abstract words to communicate with each other. If the Taniguchi's idea is correct, maybe the humans use very detailed communication with communicate the volume with each other. Why we use the abstract? So what kind of the functionalities need to generate the hierarchy of the word in the language area?
Oh, okay. Okay, that's very interesting point. And actually, there may be many kinds of answers. And one basic answer for that is kind of the information bottleneck and constraints of the kind of physical nature of the communication media. We use sound, and sound is generated by the movement, the motion of our say vocal tract, and so on. That does not have how to say the high accuracy. We have limited number of vowels and consonants, and actually also the sound wave does not how to say can propagate for 360 directions. I don't know. So the information should be encoded in a linear manner. So the spatial information cannot be used. So as a result, sequential information is required, and the categorical sequential information is used, and that limits the kind of the communication channel. So we need some sort of abstraction at the level. But we can use the sequential information because the speech signal can be a time series data. So that's the kind of the background of the invention of the syntactic system. So by using the syntactic rule, that we can embed the very complex hierarchical information in the sequence of sounds. So that's the story, I think.
In Ito-san's, the Do Re Mi Fa color person, his book actually also says something similar to what Harrison said, but also cites this evidence from magical number 7 kind of experiment, showing that in many kind of domains of the experience, we tend to fall into 4 to 7 kind of numbers in terms of sequence or categories, and that may be related to here as well. Like in the case of color category, like currently in Japanese, it seems like basic color is increasing like 18 or something, but typically it's like between 7 and 12 or something like that.
But of course, now the communication media is changing,
Right?
So that we can generate the image by diffusion model, and we can observe some brain activity and generate something, or Kanai-san's project, try to create the internet of brain. I don't know. Such kind of from the long-term view, I think that may this kind of communication media and language system can change in a long-term manner.
Yeah. Maybe Southern knows better, but I think the number of the categories and also number of the words even now are increasing over the time, right?
I think but in some cases, number of categories, number of words are reduced, decreased in time because individual communication, like a system comes to be simple.
Because of the bilingual kind of thing, like English. I don't know, it's increasing, no?
Yeah, no, that was the case.
Oh. So it's not that simple then.
Yeah. In some cases increases and some cases decreases. I think also the number of categories and vocabulary depends on community. Elementary school people, students don't need the many categories, but in academia, we need many categories. Yeah.